I came across this video on YouTube for this particular problem from um, Popular Science that was originally published as a letter in 1939, and then a solution was posted in about 40 years later. And it is now 85 years after the original letter, so it's kind of fun to see the puzzle. It's a problem with kinematics, and the reason why I think it's kind of interesting is it's a twist on how we normally approach this. We normally give you a distance, we normally give you various types of information. We don't give you time on path. And because of that, I kind of like this just for a quick sort of thought experiment. And I tried to look for some odd problems, and this is from 1977, October 1977. It was originally posted in 1939, and this, for all of you who are guffawing, is actually a pretty cool computer. I've made some modifications to the problem, slight changes to wording, and also flipping from miles to kilometers. Yes, and it is a really cool computer. It would have been one of the first ones that I would have been able to sort of find and buy at the time. So we have an initial bit of information given. DC is 15 kilometers, CB is 15 kilometers, and you have a 90-degree bend between the two. And a driver always goes at the same speed. So you just assume that there's some sort of governor on the car. And from A to C takes 30 minutes. From A to B to C takes 35 minutes. And A to D to C takes 40 minutes. What is the driver's speed? And what I'm going to try and do is go through two different types of solutions here. So starting with all of this information and these distances, I'm going to put down or recognize that I have velocities that I'm told, basically, for example, if the driver is going at 10 kilometers per minute, well, that's a lot, but 10 kilometers, whatever, 1 kilometer per minute times minute, I'd get kilometers. So I'm looking at distances, so that's what I want to put in there. I want to put distances in. So I have 35 times the velocity or speed of the driver minus 15, because that's how long it takes the driver to drive from A to B to C. 30V kilometers to get from A to C, and 40V minus 15 to get from A to D to C. And again, I'm subtracting off the bit that I know. So I'm going to approach this two different ways. The first solution is the way I would normally approach this. I really wouldn't recommend the second one normally, but you can do the second one, and it's not that hard. Easiest way to start, because it's kind of obvious. You make a bunch of right triangles. You have x plus 15, y, so x plus 15 squared plus y squared equals 35v minus 15. Then you have x, y plus 15, and that distance is equal to 40v minus 15. So again, squares, x squared plus y plus 15 squared equals 40v minus 15 squared. Now, the only other thing you can do is recognize that this distance is part of a triangle. This distance is part of a triangle. And so x plus 15 squared plus y plus 15 squared equals 30v squared. So you now have three equations and three unknowns, x, y, and v. I will admit that I use Wolfram Alpha. I didn't really want to go through all of this, but if you want the detailed solution, I will try and include it. Just have to figure out what kind of WebDrive I'll use. Solution 1a is trivial. V equals 0 and x equals minus 15 and y equals minus 15. So the driver never goes anywhere, but that's not the answer. Second solution is 0.97108. You can go out to whatever. And you get kilometers per minute, 1.84 kilometers, and 8.772 kilometers. Normally, you're not asked for kilometers per minute, you're asked for kilometers an hour. So roughly 60, so 58.27 kilometers an hour, 1.84 kilometers, and 8.77 kilometers would be the solution I would put normally on an exam, and that's probably the units you'd be asked for. Same thing here, difference is 2.9953, and it gets to be a kind of funny answer, minus 104.54, and y equals minus 7.36. So it's negative distances, which kind of just wildly sort of off, but okay. It's kind of a big change. Again, 180, so 179.72 kilometers an hour. X equals the same distances as given above. Usually I'm asked questions about exams. I'd include all three solutions. I'd include the kilometer per minute and then the kilometer per hour. That's good for part marks. But basically any solution, typically on a solution, the correct form would be the final solution in yellow. You might be asked for a different form. And in past midterms or first quizzes, I've asked for questions along the lines of kilometers per second or something of that nature. You have to be able to deal with units in this course, and this is kind of an important concept. We could go a little bit further and sort of say, let's use the law of cosines, and the law of cosines I probably should write c squared equals a squared plus b squared minus 2aby. But if you take the square root, you can square root all of that. You get this. We have a 90-degree angle down here, so right in this section right here, and this is split, not bisected, but split between the upper and lower angle. So you could say that you have 90 minus alpha and alpha, and so you could say that this, by this sort of relationship, if you put the c squared, which is really what I should do, 35v minus 15 over here equals 15 plus 30v squared minus 215 30v cos alpha. Then you could do the same thing, 40v minus 15 squared, or 40v minus 15 quantity squared, 15 squared, 30v squared minus 215 30v cos 90 minus alpha, 90 degrees. Okay, so I really should put units on these things. So you can see here that basically this section and this section are the same. These two are different, but that's not so bad. But you have two equations and two unknowns, v and alpha. So solving through for both of those, and you'll note here I switched it for the purpose of this example from 90 degrees to radians, pi over 2, and that makes it easier on me to solve through everything. And I'm going to solve this using radians. Now, again, I cheat here, and I immediately jump to Wolfram alpha, but I just jumped to Wolfram alpha just to get the kind of answers that I need without really working at it. So V is 58.27, 179.72, same as before. This is the same thing. Alpha is equal to 35, and no surprise here, this is a negative angle because we're now looking at a different sort of displacement than the original triangle that I've drawn. Both of these, again, correct answers, but this is kind of a fun question, not for anything really, other than the value of sort of thinking about kinematics. The preference for me, honestly, is solution 1, and I wouldn't do it any other way. Wolfram alpha and other tools, so SMath, Desktop, MathCAD Prime, anything that you can use that I think you can put a little bit of thought into how you solve a problem, setting up the problem, but still solving. It's not going to help you on an exam, but it will help you get through certain things. And I think one of the problems I had on this example was that when I originally solved the second solution, I put 90 into my solution in Wolfram alpha, and because I didn't use units, I kind of messed it up. If I put pi over 2 or 90 degrees, I would not